Alrighty, today we're going to be solving number 11 out of the physics textbook. And it reads, a 4-kilogram object is attached to a vertical rod by 2 strings, as shown in figure 6.11. The object rotates in a horizontal circle at a constant speed of 6 meters per second. Find the tension in A, the upper string, and B, the lower string. So you can see the figure right here, and it gives you the vertical distance of the rod and also the length of both of the strings, which is 2 meters. And so I kind of redrew the diagram over here, but I also wrote the forces. So obviously in the negative y direction is weight. It's equal to mg, and then T1 is right here. It's the tension of the first string, and T2, the tension of the second string. And then also they didn't give us the radius or theta, so you have to solve for that. So first we're going to solve for radius, and we use the Pythagorean theorem since we know the length of the string and also the length of the rod. We get that the radius is 1.3 meters, and then we're going to solve for theta, which we can do using trigonometry, because sine theta, and theta is this angle right here going from the radius to the first string, and obviously theta is going to be the same here, and this angle is also going to be equal to theta. So sine theta equals 1.5 over 2, and that theta equals 48.59 degrees. I also just solve for weight, because weight equals mg, and since it's a 4-kilogram object, weight equals 4 times 9.8 meters per second, and yet the weight is 39.2 newtons. Okay, so now in the x direction, T1 cosine theta represents the x component of the first tension, which is of the upper string. So T1 cosine theta is the x component of that top string's tension. And then T2 cosine theta is obviously the x component of the bottom string's tension. And T1 cosine theta plus T2 cosine theta is equal to mv squared over r. And once you plug in all the values that you've been given and do a little bit of algebra, you get T1 plus T2 equals 165 newtons. And we're looking for T1 and T2. So once we do that, we can do the sum of the forces in the y direction. So in the y direction, we've got the weight going in the negative y direction. T1, there will be a positive y component, and T2, there will be a negative y component. So we take the positive y component of T1, which is T1 sine theta, minus the negative component of T2, which is T2 sine theta, and then minus weight, because weight is going in the negative y direction, equals mass times acceleration, but since it's not moving in the y direction, that's 0. And so once we do more algebra, T1 minus T2 equals like the weight over sine theta. And we already solved for weight, if you remember earlier, and that's 39.2 newtons. And we get T1 minus T2 equals 52.3 newtons. So obviously we have two equations here, and this makes a very simple system of equations. So for part A, we're solving for T1, which is the tension of the upper string. And so T1 plus T2 equals 165 newtons, T1 minus T2 equals 52.3 newtons. We add those two equations together, get rid of T2, and T1 equals 108.65 newtons at 48.59 degrees up from positive x, because it's like going in that direction up from theta. And then T2 equals 165 newtons minus T1. We just kind of plugged in the T1 value, and we get T2 equals 56.2 newtons at 48.59 degrees down from positive x, because that is the tension of the second string, which is going in that direction. And that is how you solve problem number 11. Hopefully this was helpful to you guys.